So who can remind me what a proportion is? Sorry, a ratio. Towards the next page.
Like 3 to 1 means out of
Okay.
what's part.
So 3 to 1.
It's just 4 parts, and you just take 3 out of the 4 parts.
All right, we're getting crazy with it. So nice and easy. A ratio is a comparison of two amounts. Could be quantities, okay? And it's usually written as a couple things. You might see it as like 3:1, right? Or if we want to do like A:B, if you want to get away from numbers, like A:B, we might see it written as a fraction, or we might see it written as like A2B with the word 2 in there, okay? Those are the most common ways that you are going to see those ratios written. Notice that the number that appears first is in the numerator of our ratio, okay? We've talked about these before. We did scale factors for similar figures as well. So one way that you've learned how to do a ratio in the past is with a tape diagram. You guys remember tape diagrams from back in the day? Yeah. Okay, so we'll use the tape diagram and then we'll talk about algebraically how we do this. So, first question. Members of a school band are buying pots of tulips and pots of daffodils as they sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio of tulip pots to daffodil pots will be 2 to 3. How many pots of each type of flower should they buy? So what we're going to do is we're going to make what's called the tape diagram. We're going to draw ourselves essentially a long rectangle, okay? And we are going to cut this rectangle into how many parts? 5 parts. So the reason is because there are 2 parts. These first 2 squares are going to represent our tulips. And these other parts are going to represent our daffodils. Now, what we really need to do is we need to figure out what quantity, okay? What I'm going to do for right now is just give me a second. Instead of scribbling in this, I'm just going to highlight them real quick just so it's easier to write in. These are the tulips. Those are the daffodils. We want to figure out what quantity we can use to represent each box here. So this has to be the same amount, okay? Put in each box. Does that make sense? But what we know is that all of these amounts together have to make 120. So what we do algebraically is we're going to let x equal what's called our common factor. Okay? And what we're going to do is we're going to look at each of the numbers in the ratio. And all we're going to do is we're going to attach an x onto those numbers. So notice that in the first 2 boxes, we add this together. This equals 2x. If we just put an x on that, it's 2x. Okay? So we're going to say 2x is essentially just the number of daffodil pots, right? And 3x represents the number of tulip pots. What do I have to do to these 2 quantities to end up with this number 120? We just add them together, right? And this equation is going to be built using the context of your problem. You will not always add those quantities together. Does that make sense? For example, you might have something where you're talking about the length of a rectangle compared to the width, and you want to know the area. That would be something where you would multiply, okay? So you have to use the context, the question, to decide how to make this. And now we just solve for x. So 2x plus 3x is, and if 5x equals 120, then x is going to equal 24. We just divide by 5 to make that happen. Now, we're not done because it asks us to identify how many pots for each type of flower. So if we plug back into our expressions here, we know 2x, right, would be just 2 times, so that's 48. And then 3 times 24 would give us And we want to make a little statement here, so we would say, there are, you got it, 48 tulip pots and 72 daffodil pots. So you should be able to kind of leave this tape diagram behind and just understand that all you're doing is taking your ratio, you're attaching an x to both of these quantities, and you're creating an equation with those amounts. Okay? So if you would, try B, C, and D on your own here, and we'll kind of go through about every couple minutes and talk about one of the questions. So you can pause it and try this now. So for question B here, we have x is our common factor. We made our equation, attach an x on each of these numbers. Because we're doing angles that are supplementary, they add to 180, so we're going to add them together. 36 is what x should equal. And then when you plug back in, you just need the largest, or it says both angles, since x is 36, and that's one of them. 4 times that gives you 144, and that's the other one. All right, take another minute to try up B if you haven't finished that already. All right, if you guys are checking out letter C, you can see we did the same thing with the common factor. We attached an x on it, got 3x, 5x, 6x. Because it's a perimeter of a triangle, we're going to add all the sides to give you 98. You should get 14x equals 98, and then just divide out by 14 to get 7. And then when you substitute back into the 3x, 5x, and 6x, you should get sides of 21, 35, and 42. So the longest side is our 42. And then the last question, you should get answers of?
12, 21, and 27.
All right, 12, 21, and 27. So same thing. X is a common factor. Attach an x onto this. Since it's perimeter, add them to get 60. X is 3, and then plug back in. Any questions on those problems? Okay. So heading over to the next page, we're going to talk about the next topic, which is a proportion. So who can tell me again what a proportion is? So we know a ratio is a comparison of two quantities using a fraction usually. So a proportion is not exactly the same thing, in a way. These are examples of proportions, right? Each of these things, the left and the right side, is a what are equal to each other. The fractions, another word for a fraction is ratio. So a proportion is two ratios that are equal. You may also see the word equivalent in here, okay? But that is what a proportion is. So how do we solve a proportion? We just by cross multiplying. Now remember, when you cross multiply, you usually should leave the product on the same side where the numerator is. So when I cross multiply the 6 and 4, I should put it on the left because the 6 is on the left. Now that's when you write it. Does it really matter in terms of solving the equation? No. But that's normally how you get to that amount. And then the last step would be to divide by 5, and we would get an answer of, all right. Now, on the second question where you have a quantity, you have this y plus 4, this binomial, what do you need to remember you need to do as you cross multiply? Good. So we need to make sure we are distributing that 3 into both parts, both terms of the y plus 4, okay? So after you're done distributing, remember you want to get rid of your parentheses. You want to combine like terms if you can on each side, and then get all the y's on one side. So we'll move the 3y over to keep the y's positive. And then the last step is to get y by itself. So divide out by 6, and we should get y equals 2. So try C and D and see if you can remember how to do E, but we'll go over that in a couple minutes here. So try it on your own, and we'll compare answers. A little bit of time here. Let's take a look at our answers. So for number C, when we distribute through, make sure we distribute the 3 through the m plus 1. And then, once again, there's no like terms to combine, so move the m back over to the other side. Divide out by 12, and we should get 1/4 for m. With 0.25 works. Common mistake on the last one here, after we cross multiply, is ending up with just an answer of 6. Very good. Anytime you physically take a square root, you have to remember that you have to include a plus or minus. You could plug in a positive or negative 6 into a squared to get 36. So whenever you physically take the square root, you have to remember that you need to introduce the plus minus here, okay? The reason why the right side doesn't need a plus minus is because we're squaring a, and any number that you square is always positive. So this side is just restricted to positive, but this side could be both positive or negative, okay? So just remember, we want that plus minus here, and then we'd end up with full credit, okay? Questions on how we did that one? Same approach to the next one, which means we end up with 24 equals. Did anyone get answers for this one? Caitlin, what'd you get? So what your final answer then, if it's... Okay. All right, so we think one of the answers is 4, and the other answer is -6. That's what we think the answers are. Okay, so let's go through how to do this one. As soon as we cross multiply it and we notice we have that tells us it is a quadratic, and in order to solve a quadratic, there's a few options. Number one, if you are a fan of the quadratic formula, you are more than welcome to use that. You guys remember you're from the famous song of x is equal to -b, right? Oh, yeah, we got that one. You also have your completing the square, which is an option. It's got to be, we'll talk about that later. And the third one is you should be able to factor and solve, okay? So, for where? It's just got to have a positive x squared. Nothing in front of it. So if it says got something in front of the x squared, they can't use it unless you divide out. What we want to do, though, before we solve this one is to get all this thing equal to what first? To 0. So we want to bring that 24 from the left back over to the right side. Remember, we've talked in the past about using our diamond here to kind of help us factor. So we want numbers that multiply to what? Careful. Not just 24. Negative 24. And add or subtract give us +2. So two numbers that you could think about doing this would be. All right, so -4 and +6. You guys agree what happened? There are other numbers that might work, like 10 and 2, but we can't get 2 out of that, right? And then I think 6 and 4, and then 8 and 3, but we can't get 2 out of that as well. So once we do that, those numbers, we know we're going to break this apart into x, and then the -4 and the +6 fall into our factors. We want to make sure we keep this as equal to 0 because it has to be an equation. And then you could jump right into your solutions, right? Where if x is equal to, if x minus 4 is your factor, the answer is, and if x plus 6 is your factor, then the answer is, but behind the scenes, remember we're technically using what's called the zero product property, which is we're setting each of these two things equal to 0, with that little or in between, and then that's where that solution is coming in, okay? Does that make sense? But if you had the factors and you had your answers, I would take that as is, okay? Questions? Cool. Please remember that if you have a calculator, you also could use NSolve to do every one of these, except these bottom two will only give you one answer at a time. It gives you the answer closest to 0. So if you did this, it would give you the 4. You would have to do a little bit of work to get the -6, and we'll go over that a little bit later, though. We got to get through some stuff today. So, questions on proportions, ratios? Okay. This is what we're working on today. So let me ask you guys a question for number 1. If you were to use the graph to find the midpoint, what would you do? without using the midpoint formula, how can I find the midpoint of segment AB here? Well, Pythagorean theorem gives me the distance. So you guys are doing some stuff over their hands. What are you doing? Christian?
You want to find the, what is it, the slope?
Okay, so with slope meaning?
As in to the y of b or the x of b.
Okay, so we're going to count. How do we get from A to B? We're going up, looks like 8, and then we're going to go over 4, and then 12 more, so 16. And so if I wanted to find the midpoint, I would just what? Divide those by 2, right? So I would take 8 and kind of divide by 2 or multiply by a half to get the amount that I'm actually going to move up, right? And then take 16 times a half and get, and I would move over 8 from this point right there. And that would point me to the midpoint. Okay? So what was the process that we used? The first thing we did was, okay, so count the rise and run. We'll say from A to B. Okay, and then what did we do? Okay, so divide those by 2, or we'd say like move half of that amount, right? From where though? Now careful, where's that? From A, right? So move 1/2 of the rise and run, right, from point A. Now, this point is technically cutting this into a ratio of 1 to 1, where this section over here is equal to this section. They're at a ratio of 1 to 1, correct? But how much of the line, where in the line is this point? How far up the line does this point actually go? So it's halfway, right? 1/2 of the line. So this distance is half of the line, but it's cutting the line into a ratio of 1 to 1. Does that make sense? Okay. So what we are going to do is we're going to use our tape diagram skills and our knowledge of how to do the slope graphically to answer questions like this example. Given points A and B, find the coordinates of point C so it sits 2/5 of the way along segment AB. Now, if you think about a tape diagram, 2/5 of the line is really what ratio? It's a ratio of 2 to 3, right? So what oftentimes is going to happen is they're going to give you this ratio, and you need to create the fraction of the line that you're looking for, okay? You're going to want to take the 2 to 3 and write it as a fraction of 2/5. Then all we're going to do is what we did for the last question, which is step 1 was find the rise over run. Now the rise is technically the change in y, and the run is the change in x. So if you don't have a graph, you can think about doing our little like leapfrog method and say, how do I really get from -4 to 12? I just add 16. And how do I get from 5 to 13? We add 8. And I just did this right down here. You guys can see that's the same thing. Now, remember that what we really did after that is we multiplied both of those numbers by a half, right? Because we wanted to move halfway. So what I'm going to do is multiply both of those numbers by 2/5. So I do 2/5 of 16 and 2/5 of 8. And then all I'm going to do is take these two quantities, 3.2 and 6.4, and add them to the coordinates from point A. -4 plus 6.4 gives me the new coordinate, which is what point C is, and 5 plus 3.2 gives me the new y coordinate of point C. And I'm done. That's it. Okay? So the hardest things to kind of do are to come up with a ratio, given the ratio, to come up with a fraction. Does that make sense? And then once you calculate the rise and the run, how to figure out your new point. Those are the two things. So we're going to go through a few of these questions together. Okay? First, we'll do it on the graph, and then we'll do it without a graph. So let's look at number 1. Find the point on the directed segment, that's what this is called, okay, from negative 2, 0. So here's point negative 2, 0. Why don't we call this A, for lack of a better letter here, and then 5, 8. There's point B. Okay? And we're cutting this in a ratio of 1 to 3. So if we think about our tape diagram, okay, and I'm cutting this in a ratio of 1 to 3, what fraction of the line am I actually creating? It's 1 part to 4 total parts, right? Does that make sense to everybody? Okay, 1/4. So what I'm going to do, Claire, is we're going to count the rise and the run to get from A to B. Okay? And we got to think that technically this is a line segment. So we have like a line connecting A to B. How do I get from A to B? I have to go up 8 and over 7. Now, I actually want to move 1/4 of that amount, right? So if I went up 1/4, what I like to do for myself is write delta x for change in x. What was the change in x, by the way? 7. We're going to multiply that times our fraction, which is, and that comes out to be, careful, 7. 1.75, right? 1 whole, and then 3/4 left over. So instead of going over 7 units, I'm going to go over 1, and then 3/4 of 1, which is right there. Okay? Does that make sense? And then the change in y was 8. And if we take 1/4 of 8, we get, so instead of going up all 8, I'm going to go up 2. And if I go up 2 and over 1 3/4, we land on our point, which is right there. And what are the coordinates of this point that we're landed at? Now, we got to be careful. Negative 0.25. Positive 2. Now, how we're going to do this easily is we're going to start with the coordinates of point A, which are just negative 2 and 0. And I'm just going to add these two answers, delta x and delta y, to these amounts. So if I add 1.75 to the x coordinate, what does that give me? 0.25. Right? You guys agree that's negative 0.25? And Claire, if I add 2 to 0, I get... And so this point, my new point, has those coordinates, which is just the sum of those two amounts. That's it, we're done. Okay? So we found the rise over run, we multiplied by our fraction, and then we added these two quantities to the first point that we started from. And we're done. Okay? Now let's do this graphic. Let's do this without using a graph. All right, step 1. We need to figure out what the change in x and what the change in y is. So, starting from point A, I'm going to draw an arrow that goes from negative 7 over to 14, the x's. How do we get from negative 7 to 14? Add 21. And how do I go from negative 2 to 12? Okay. Now, this already gives me a fraction, so all I have to do is multiply 21 and 14 by 4 over 7. Now, it's really the same as doing 21 divided by 7 times 4. So that gives me 12. And 14 divided by 7 times 4 is 8. So all I'm going to do is take current point A, which has these coordinates, and do what to them? Add what number to negative 7? 12, because that was the change in x. So that goes with the x coordinate. And add what to the negative 2? Because that was the change in y. And my new coordinate is 5. And you're done. Homework tonight, I would like you to try 3 and 4. Okay? And we'll see you guys tomorrow. And have a great night.